Welcome to your practice test 5. Next section. The neural network fundamentals. Question 1. Which weight initialization scheme is generally recommended for layers using EAT and activations? Option 1. Naming initialization. Option initializing all weights to the same constant. Option Behavior by Valorot initialization tuned for tan by sigmoid. Option A. Zero initialization. The correct answer is V. The initialization scales initial variance by 2 by an underscore in, matching it as tendency to zero out half its inputs, which keeps signal variance stable across deep layers. Question 2. High to large model training runs often use learning rate warm-up followed by a decay schedule. Option Warm-up avoids instability from large early updates, decay enables fine convergence later. Option It permanently increases the batch size. Option It removes the need for an optimizer. Option A It encrypts the gradients. The correct answer is V. A short warm-up ramps the learning rate up to avoid destabilizing the freshly initialized model. A subsequent decay, for example, cosine, lets training settle into a good minimum. Question 3. How does A1 regularization differ in effect from A2 regularization? Option A. A1 tends to drive some weights exactly to zero sparsity. A2 shrinks weights smoothly. Option A1 and A2 always produce identical weights. Option A2 produces sparse weights. A1 never shrinks weights. Option A. Rather affects the weights. The correct answer is V. 1. Absolute value penalty yields sparse solutions and can perform feature selection. A2 squared penalty discourages large weights but rarely produces exact zeros. Question 4. Which conditions are likely to cause underfitting high bias? Select all that apply. Option A model that is too simple for the data's complexity. Option excessive regularization. Option draining for too few iterations. Option I using a sufficiently expressive model trained to convergence. The correct answers are V and A. Underfitting stems from too little capacity, too much regularization, or too little training. When adequately expressive, well-trained model usually fits the underlying pattern. Next section. Transformer architecture and attention. Question 5. That is the primary benefit of collage attention. Option A. It computes exact attention with far less memory and higher speed via aware tiling. Option It approximates attention by dropping most tokens. Option It removes the need for the softmax. Option It only works on numerous. The correct answer is V. Collage attention reorders the attention computation to be aware, keeping intermediate results in fast on-chip variable and avoiding materializing the full A times A matrix in SOVI, exact, faster, and memory efficient. Question 6. That problem do multi-query and grouped query attention also by Vasu primarily address? Option A. Reducing the size by bandwidth of the YAG cache to speed up inference. Option Increasing the vocabulary size. Option Eliminating the feed-forward layers. Option A. Removing positional information. The correct answer is V. Also by Vasu share key by value projections across attention heads, shrinking the YAB cache and its memory bandwidth during autoaggressive decoding while largely preserving quality. Question 7. In modern transformer designs, why is per-layer normalization word high often preferred over post high? Option A. It improves gradient flow and training stability for very deep models. Option It increases the parameter count substantially. Option It removes the residual connections. Option A. It eliminates the attention mechanism. The correct answer is V. Placing layer norm inside the residual branch, word high, yields better behaved gradients, allowing stable training of deep transformers often without elaborate warm-up. Question 8. Which techniques are used to extend or handle longer context in transformer layers? Select all that apply. Option A. Open scaling by position interpolation. Option memory efficient attention, for example, collage attention. Option A. Parse or sliding window attention. Option A. Forward coding a maximum of 5 tokens. The correct answers are V and A. Position interpolation by open scaling, efficient by sparse attention, and sliding window approaches extend context. Happing tokens to a tiny number does the opposite. Next section. Third fundamentals and tokenization. Question 9. That is knowledge distillation in the context of DIAS. Option A. Training a smaller student model to mimic a larger teacher model's outputs. Option Removing all training data from the model. Option Encrypting the model weights. Option A. Increasing the model to twice its size. The correct answer is V. Distillation transfers behavior from a large teacher to a compact student, often via soft labels by logits, yielding a smaller, cheaper model that retains much of the teacher's quality. Question 10. Getting the sampling temperature to zero during generation typically results in what? Option A. Greedy, near deterministic output that selects the highest probability token. Option A. Maximum randomness and creativity. Option A. The model refusing to answer. Option A. Have a larger context window. The correct answer is V. Temperature zero collapses the distribution to its mode, so decoding becomes greedy and barring ties by non-determinism, reproducible, useful when consistency is required. Question 11. Which statement about the embeddings by representations is accurate? Option A. Contextual models produce different vectors for the same word depending on surrounding context. Option A. Each word always maps to one fixed vector regardless of context. Option A. Embeddings contain no semantic information. Option A. Embedding dimension must equal the vocabulary size. The correct answer is V. Transformer is produce contextual embeddings. The representation of a token depends on its context, unlike static embeddings that assign one vector per word. Question 12. Which statements about subword tokenization and context length are true? Select all that apply. Option A. Non-English or code text can tokenize into more tokens per character. Option A. Lower tokens for the same text consume more of the context budget. Option A. A single long word may split into multiple subword tokens. Option A. Token count has no effect on inference cost. The correct answers are V and A. Tokenization efficiency varies by language by content. Token counts drive context use and cost, and words can split into several tokens. Token count directly affects compute. Next section. Prompt engineering. Question 13. That is a prompt injection attack. Option A. Malicious input that overrides or manipulates the model's intended instructions. Option A. A way to speed up tokenization. Option A. A method to compress prompts. Option A. A verbal memory optimization. The correct answer is V. Prompt injection embeds adversarial instructions, often in retrieved or user content, that hijack the model's behavior. For example, ignore previous instructions, posing a real security risk for TI apps. Question 14. Which prompting approach best helps obtain reliably parsable structured output? For example, Option A. Explicitly specifying the schema and using constraint by structured output decoding. Option A. Asking vaguely for some data. Option A. Raising the temperature to maximum. Option A. Removing all instructions. The correct answer is V. Rotating the exact schema, giving an example, and using by grammar constraint decoding or function calling greatly improves the reliability of machine parsable output. Question 15. Which measures help mitigate prompt injection in TI applications? Select all that apply. Option A. Separating and clearly delimiting trusted instructions from untrusted content. Option A. Validating by sanitizing retrieved or user provided content. Option A. Constraining tool by permission scope and adding output checks. Option A. Blindly executing any instruction found in retrieved documents. The correct answers are V and A. Delimiting trusted versus untrusted text, sanitizing inputs, least privileged tool access, and output validation reduce prompt injection risk. Blindly trusting retrieved instructions invites attacks. Next section. Fine tuning to rev and pineapple. Question 16. In rev, increasing the rank of the adapter generally has what effect? Option A. Lower trainable capacity, potentially better fit, at the cost of more parameters by memory. Option A. Fewer trainable parameters. Option A. It freezes the adapter. Option A. It deletes the base model. The correct answer is V. The 2A rank controls the dimensionality of the low rank update. Fire adds capacity and can improve adaptation, but increases trainable parameters and memory. Too high erodes efficiency. Question 17. Compared with full alpha reward model plus power, a practical advantage of GEMO is that it Option A. Avoids training a separate reward model and the complexity of an while loop. Option A. Requires no preference data. Option A. Eliminates the base by reference model. Option A. Only works for vision models. The correct answer is V. Nemo optimizes a closed form preference loss directly on chosen by rejected pairs, removing the separate reward model training and unstable cover loop, simpler and often more stable. Question 18. Which hyperparameters are important to tune when applying to web? Select all that apply. Option A. Rank. Option A. Alpha scaling factor. Option A. Which modules by layers to adapt, for example, attention projections. Option A. The monitor's refresh rate. The correct answers are V and A. Rev tuning involves rank, alpha, dropout, and the set of target modules. Display settings have nothing to do with model adaptation. Next section, Python libraries for the miss. Question 19. How does PyTorch claim differ from standard distributed data parallel game? Option A. Claim shots by shots model parameters, gradients, and optimizer states across hubs to save memory. Lime replicates the full model on each hub. Option A. Claim and Lime are identical. Option A. Lime shots parameters, Claim replicates them. Option A. Rather supports multi-hub training. The correct answer is A. Lime keeps a full model replica per hub and syncs gradients, Claim shorts parameters by gradients by optimizer states across hubs, materializing layers as needed, enabling much larger models. Question 20. That does gradient checkpointing activation recomputation trade-off? Option A. It saves memory by recomputing activations during the backward pass at the cost of extra compute. Option A. It saves compute by storing more activations. Option A. It removes the need for backpropagation. Option A. It increases the learning rate. The correct answer is A. Gradient checkpointing stores only a subset of activations and recomputes the rest in the backward pass, cutting peak memory so larger models by batches fit at the cost of extra forward computation. Question 21. That is the benefit of mixed precision training, for example, POCO 1, 6 by OCO 1, 6 with POCO 3, 2 master weights. Option A. Faster training and lower memory use with little accuracy loss. Option A. It guarantees zero numerical error. Option A. It eliminates the need for overbooking. Option A. It only affects inference, never training. The correct answer is A. Mixed precision uses lower precision math, leveraging tensor cores for speed and memory savings while keeping higher precision master weights by loss scaling to preserve stability and accuracy. Question 22. Which techniques help reduce our memory consumption during large model training? Select all that apply. Option A. Gradient checkpointing. Option A. Mixed precision POCO 1 6 by OCO 1 6 training. Option A. Parameter by optimizer state sharding delay by column. Option A. Storing every intermediate activation in full POCO 3 2. The correct answers are A and A. Heck pointing, mixed precision, sharding delay by column, and offloading reduce training memory. Leaping all activations in POCO 3 2 increases memory pressure. Next section, ABU and training attack. Question 23. That does the LILO frameworks, NEMO checkpoint typically encapsulate? Option A. Loadal weights together with configuration and artifacts, for example, tokenizer for easy reuse. Option A. Only a screenshot of the training loss. Option A. Viewable firmware. Option A. Nothing usable for inference. The correct answer is A. One NEMO file bundles the model's weights, hyperparameter config, and supporting artifacts like the tokenizer into a single archive, simplifying saving, sharing, and deployment. Question 24. In NCA-GENL, what is the main purpose of in-flight continuous batching combined with a page jab cache? Option A. Maximize utilization and throughput for variable length requests while controlling memory. Option A. Train the model on streaming data. Option A. Encrypt requests end-to-end. Option A. Reduce the model's accuracy intentionally. The correct answer is A. Continuous batching lets requests enter by leave the running batch as they start by finish, and the page jab cache manages memory efficiently, together sustaining high throughput under mixed, variable length traffic. Question 25. That do direct audio technologies enable in large clusters? Option A. Direct data transfers between hubs and layers bypassing the hub to cut latency. Option A. Automatic labeling of training data. Option A. Rendering 3 games only. Option A. Converting models to spreadsheets. The correct answer is A. Open direct audio lets network adapters read by write memory directly, bypassing host memory and the hub to reduce latency and boost bandwidth for distributed training and inference. Question 26. Which ABU technologies help scale training across many hubs by nodes? Select all that apply. Option 1. YUM for collective communication. Option routing by which high bandwidth interconnects. Option Degatron style tensor by pipeline parallelism. Option A. A single consumer node drive as the only interconnect. The correct answers are A and A. Levada Tank by which direct and Legatron parallelism enable large-scale distributed training, while the drive is irrelevant as an interconnect. Next section, Triton Tensor Array and deployment. Question 27. That is the purpose of the ABU Triton Nodal Analyzer. Option A. Do profile and recommend deployment configs, batch size instances that meet latency by throughput goals. Option A. Do label training images. Option A. Do write the model source code. Option A. Do replace the driver. The correct answer is V. Dodal analyzer sweeps configurations, concurrency, batch size, instance groups, and reports latency by throughput by memory trade-offs, helping you choose an optimal written deployment setup. Question 28. Triton supports multiple backends. What does this mean? Option A. It can serve models from different runtimes by frameworks, TensorFlow, runtime, PyTorch, Python, etc. Option A. It can only serve a single model format. Option it exclusively runs on Hummus. Option A. It is limited to image models. The correct answer is V. Triton's backend architecture lets one server host models from many frameworks and even custom Python logic, unifying deployment across heterogeneous model types. Question 29. How can a response cache improve entire serving system? Option A. By returning stored results for repeated identical requests, reducing latency and compute. Option A. By retraining the model on each request. Option A. By deleting the model weights. Option A. By increasing every request latency. The correct answer is V. Matching responses or prefixes by YAG states for recurring inputs avoids recomputation, cutting latency and cost for repeated or shared prefix queries. Question 30. Which considerations matter when deploying and to production with Triton by year? Select all that apply. Option A. Latency and throughput targets by was. Option A. Open memory and YAG cache sizing. Option A. Availability monitoring and auto scaling. Option A. The desktop wallpaper of the server. The correct answers are V and A. Production deployment weighs was memory by YAG sizing, batching, scaling, monitoring, and cost. Cosmetic use settings are irrelevant. Next section. Eve and Hive application development. Question 31. That is the idea behind parent document or small to big retrieval in Eve. Option A. Retrieve on small, precise chunks but feed the larger parent context to the TIE. Option always empt entire books as single vectors. Option never use any chunking. Option A. Retrieve random passages. The correct answer is V. Small to big retrieval indexes fine-grained chunks for precise matching, then supplies the surrounding parent passage to the TIE so it has enough context to answer well. Question 32. Why might a question require multi-hop retrieval? Option A. The answer depends on combining information from multiple documents by steps. Option A. The model has too many parameters. Option A. The open is overheating. Option A. The prompt is empty. The correct answer is V. Multi-hop questions need evidence chained across sources. For example, find K in Docker, then use that to find J in Docker. Iterative or query decomposition retrieval handles these. Question 33. Which are advanced techniques to improve VO quality? Select all that apply. Option A. Query rewriting by expansion. Option E. Ranking retrieved candidates with a cross encoder. Option hybrid semantic plus lexical search. Option I. Returning the same fixed document for every query. The correct answers are V and A. Query rewriting, re-ranking, hybrid search, and multi-hop retrieval improve VO. A fixed response regardless of query is not retrieval at all. Next section. Data preprocessing and feature engineering. Question 34. Why is aggressive deduplication of pre-training text important for TIEs? Option A. Duplicated data wastes compute and can cause memorization and skewed distributions. Option A. It increases the vocabulary size. Option A. It encrypts the data set. Option A. It always reduces accuracy. The correct answer is V. Moving near duplicate documents reduces wasted training on repeated text, lowers memorization risk, and prevents overrepresented content from biasing the model. Question 35. That is benchmark contamination test set leakage for TIEs. Option A. Then evaluation benchmark data appears in the training corpus, inflating scores. Option A. Then the open is contaminated with dust. Option A. Then tokenization fails. Option I. Then the model has too few parameters. The correct answer is V. Contamination occurs when tests by benchmark examples leak into pre-training data, so high benchmark scores reflect memorization rather than genuine generalization, motivating careful data filtering. Question 36. In curating a web-scale corpus, why apply quality filtering, for example, heuristic or classifier-based? Option A. To remove low-quality, boilerplate, or harmful text that would degrade the model. Option A. To make the dataset as large as possible regardless of quality. Option A. To translate everything to binary. Option A. To overclock the hubness. The correct answer is V. Quality filtering keeps cleaner, more informative text and drops spam by boilerplate by toxic content, improving model quality and training efficiency. Quality often matters more than sheer size. Question 37. Thai can tokenizing source code or multilingual text be challenging for a primarily in English trained tokenizer? Option A. It may fragment into many tokens, hurting efficiency and representation. Option A. It always produces exactly one token. Option A. It changes the urban architecture. Option A. It deletes the model weights. The correct answer is V. Tokenizers optimized for English can split code symbols or non-Tibetan scripts into many subword by byte tokens, increasing sequence length and cost and weakening representation quality. Question 38. Which steps are typically part of curating a large pre-training dataset for entire? Select all that apply. Option A. Deduplication of near identical documents. Option A. Quality and toxicity filtering. Option A. Removing benchmark by test contamination. Option A. Intentionally duplicating the test set into training. The correct answers are V and A. Duration includes deduplication, quality by toxicity filtering, QA handling, and decontamination. Injecting test data into training is harmful contamination. Next section. Experiment design. Question 39. In an bio test, what does statistical power refer to? Option A. The probability of detecting a true effect when one actually exists. Option A, the electrical wattage of the worm. Option A, the number of model parameters. Option A, the size of the model file. The correct answer is V. Power is 1 minus the false negative rate, the chance the test detects a real effect. Adequate sample size and effect size are needed to achieve sufficient power. Question 40. A risk of a single fixed train by validation split versus cross validation is that option A. The performance estimate can be high variance and depend heavily on which examples landed in validation. Option A. It is impossible to compute any metric. Option A. It guarantees overfitting. Option A. It removes the need for a model. The correct answer is V. With limited data, one split gives a noisy estimate sensitive to the particular partition. Cross-validation averages over multiple splits for a more stable estimate. Question 41. That is the multiple comparisons problem in experimentation. Option A. Testing many hypotheses increases the chance of false positives unless corrected. Option A. Comparing two models is impossible. Option A. It only occurs with images. Option A. It eliminates the need for p-values. The correct answer is V. Running many tests inflates the family-wise error rate, corrections, Monferroni, when Gemini Fochberg, control false discoveries when many comparisons are made. Question 42. Which issues can threaten the validity of an experiment's conclusions? Select all that apply. Option A. Data leakage between train and test. Option A. Evaluating on a non-representative test set. Option A. Tuning hyperparameters on the test set. Option A. Using a held-out test set only once for final evaluation. The correct answers are V and A. Leakage, unrepresentative test data, and tuning on the test set all undermine validity. Reserving the test set for a single final evaluation is exactly what you should do. Next section, nodal evaluation and metrics. Question 43. That does a benchmark like it primarily measure for entire. Option A. Road multitask knowledge and reasoning across many subjects via multiple choice questions. Option A. Inference latency in milliseconds. Option A. Hubble power draw. Option A. The size of the tokenizer vocabulary. The correct answer is V. Didn't lascive multitask language understanding tests accuracy across 57 subjects, serving as a broad proxy for entire knowledge and reasoning breadth. Question 44. Nodal calibration, for example, measured by expected calibration error, concerns what? Option A. Whether predicted confidences match actual correctness frequencies. Option A. How fast the model runs. Option A. The number of layers. Option A. The orbit temperature. The correct answer is V. A well-calibrated model stated confidence matches its empirical accuracy. For example, 80% confidence predictions are right-tiled 80% of the time. Young quantifies the gap. Question 45. For extractive question answering, why are both exact latch nay and the one commonly reported? Option A. Nay is strict all or nothing, while token level to 1 credits partial overlap with the reference answer. Option A. They are identical metrics. Option A. Nay measures latency and to 1 measures memory. Option A. Both ignore the reference answer. The correct answer is V. Nay requires the predicted span to match exactly, per 1 measures token overlap, rewarding partially correct answers. Reporting both gives a fuller picture of show performance. Question 46. Which evaluations are important for assessing the safety and robustness? Select all that apply. Option A, adversarial by red team testing for harmful outputs. Option A, equipoise and fairness evaluation across groups. Option A, robustness to prompt perturbations and jailbreak attempts. Option I, measuring only the model's parameter count. The correct answers are O and A. BAFT by robustness assessment includes red teaming, bias by fairness audits, jailbreak resistance, and toxicity testing. Parameter count is not a safety measure. Next section, data analysis and visualization. Question 47. A violin plot conveys what additional information compared to a basic box plot? Option A, the full shape by density of the distribution, not just summary quartiles. Option, the exact source code. Option, only the single maximum value. Option A, the upper utilization. The correct answer is V. The violin plot overlays a kernel density estimate on box plot style summaries, revealing multimodality and distribution shape that a box plot alone hides. Question 48. Which dimensionality reduction techniques are commonly used to visualize high-dimensional embeddings into a option option The correct answer is V. How linear and divine by nonlinear project high-dimensional vectors like embeddings into 2A by 3A to reveal clusters and structure for visualization. Question 49. Then visualizing clusters of the embeddings with T-by, what is an important caveat? Option A. Distances and cluster sizes in T-by plots can be misleading and are sensitive to parameters. Option T-by guarantees a perfect, unique layout every run. Option T-by preserves all global distances exactly. Option T-by requires no data. The correct answer is V. T-by preserves local neighborhoods but can distort global distances and cluster sizes. Its output depends on perplexity and randomness, so interpret with care. Question 50. Which are appropriate choices for exploring and presenting high-dimensional data? Select all that apply. Option A, go to capture major axes of variance. Option nib by T-by to reveal local cluster structure. Option correlation heatmaps among features. Option a single pie chart of all 768 embedding dimensions. The correct answers are V and A. How live by T-by and heatmaps help explore high-dimensional data. A pie chart of hundreds of dimensions is uninformative. Next section, AVM and accelerated data machines. Question 51. NLP provides one accelerated versions of which kinds of algorithms? Option A, clustering, regression, dimensionality reduction, and nearest neighbors. Option A, only deep transformer training. Option A, only image rendering. Option A, only database transactions. The correct answer is V. NLP accelerates classical k-means, linear by logistic regression, random forest, and k mirroring scikit-learn with large speedups. Question 52. How can an accelerated boost benefit large tabular workloads? Option A. It trains gradient boosted trees much faster using the for example, the GPU_hist by device tree method. Option A. It converts trees into images. Option A. It only runs on a single core. Option A. It removes the need for training data. The correct answer is V. The use of a histogram tree method accelerates training of gradient-boosted decision trees on large datasets and integrates with LLM for end-to-end pipelines. Question 53. Then a dataset is larger than a single memory in LLM, which approach helps? Option A. Let's asking out for multi-hub by out-of-core processing or enable memory spilling. Option immediately give up, it is impossible. Option convert the data to a single integer. Option A. Print the data to paper. The correct answer is V. Dask and Yoke distributes work across multiple hubs by nodes, and unified memory by spilling lets workloads exceed device memory, so large datasets remain tractable. Question 54. Which capabilities support an end-to-end machine learning workflow? Select all that apply. Option A. Yoke for data loading and feature engineering. Option A. For model training. Option integration with OpenCupOS. Option I. Requiring all computation to move back to the one between steps. The correct answers are V and A. Now, Miller, Nivraf, and OpenCupOS keep the pipeline on open end-to-end. Forcing one round trips between steps defeats the acceleration. Next section, alignment and resolve. Question 55. That is reinforcement turning from weak feedback. Option A. Using a me model guided by principles to generate preference labels instead of relying solely on humans. Option training with no feedback at all. Option A. Purely hardware optimization. Option A. A method to shrink the tokenizer. The correct answer is V. Labeling replaces or augments human preference labeling with generated feedback, often principle guided, as in constitutional way, reducing labeling cost while aligning behavior. Question 56. When aligned assistant must refuse a harmful request even though refusing is less helpful. This illustrates which tension. Option A. The trade-off between helpfulness and harmlessness. Option A. The trade-off between Pogo 1, 6 and Pogo 3, 2. Option A. The trade-off between Nagog and Pandas. Option A. The trade-off between Num and Nagam. The correct answer is V. Malignment must balance being maximally helpful with being safe by harmless. Sometimes the safest action, refusing or redirecting, is intentionally less helpful to the literal request. Question 57. Which types of data are used across the stages of aligning a chatter? Select all that apply. Option A. Human written demonstration responses for supervised fine-tuning. Option A. Human preference comparisons chosen versus rejected. Option A. Principle by rubric-based feedback review. Option A. Randomly generated gibberish as gold responses. The correct answers are V and A. Malignment uses demonstrations like preference comparisons refer by ego and feedback review. Random gibberish provides no useful supervision. Next section. Trustworthy way ethics, ways and safety. Question 58. That is a jailbreak in the context of the safety. Option A. A crafted prompt that bypasses the model's safety guardrails to elicit disallowed content. Option A. A method to speed up inference. Option A. A type of a cooling. Option A. A data compression algorithm. The correct answer is V. Jailbreaks use adversarial phrasing, role play, or obfuscation to circumvent safety policies. Defending against them requires layered guardrails, training, and monitoring. Question 59. Why are guardrails often applied at the input and output of an application? Option A. Input checks block unsafe by malicious prompts while output checks catch unsafe or off-policy responses. Option A. Because input and output are the same thing. Option A. To increase the temperature. Option A. To remove the need for any model. The correct answer is V. Defense in depth screens incoming prompts, for example, injection, disallowed requests, and outgoing responses, for example, toxicity, leakage, since neither check alone catches every failure. Question 60. Which mechanisms contribute to safer deployments? Select all that apply. Option A. Input by output guardrails and content moderation. Option A. Topical and policy constraints, for example, hero guardrails. Option A. Continuous monitoring, logging, and red teaming. Option A. Granting the model unrestricted access to all systems and secrets. The correct answers are V and A. Guardrails, policy constraints, monitoring, least privilege design, and red teaming improve safety. Unrestricted system access dramatically increases risk. That completes the practice test. Review the explanations for any questions you missed, and good luck on your certification exam.